I'm Jason, and I will be talking with you about synchronizing widgets. When we talk about synchronizing widgets, what kind of problem are we trying to solve is when we have multiple widgets, how do we communicate between them effectively? So we're going to go over with tool list. We have sorry. One method we can use is cursor tracking. So when we have multiple widgets that they have, we want to be able to show relationships in coordinate space where if you mouse over like one location, where is it on another widget? So let's show a basic. So we have right here a basic setup with 4 widgets. And as you can see right here, right now, cursor tracking isn't set up. So even though you can mouse over on one widget, you don't know really where it is elsewhere. So what we can do is we can use tool listeners. With the crosshair tool, we can listen to whenever the position changes, we can get that position and then set that for other widgets. So we're going to go over here. Can everybody see that? Or do we need to zoom in a little bit or zoom in? All right. So right here, what we're doing is we're iterating through each of the widgets. We're getting the crosshair tool and adding a listener for position change. So whenever the position changes, you get like where the position has been changed to, that you can use to get references to other widgets, and then access the same crosshair tool on those widgets and set position. Now we can see that the cursor is synchronized across all of the other widgets. Another thing we can do is widgets have might have a highlighting implementation where you can highlight certain data points, and this is pretty similar where we listen to where we listen to a tool, and when we get the events, we can process that. We can process the data from the cursor position and use that to highlight indices on another widget. So this is without highlighting enabled. As you can see, we can try to mouse over this wall log, but we don't really see any changes on this cross plot. You see from now, when we mouse over the wall log, it takes the depth level from the wall log and then calculates which indices we need to highlight on the cross plot. So now we get it to the view synchronizer. The view synchronizer solves a problem where we need to maintain consistent zoom levels between widgets. So if you zoom in on one widget, you want to be able to see that. You want to see that same zoom level change represented on another widget. Or if you pan it around, you want to be able to see that same panning on another widget. Without the view synchronizer, you can still achieve this by attaching listeners to transformation changes, But the problem with this is that you have to attach listeners to every single widget. So this takes time, takes a lot of code, and the more widgets you have, it doesn't scale very well. Using the ViewSynchronizer, it's a high level. It abstracts a lot of this handling so that it's easy to set up, and then it's easy for you to maintain. As you can see, it's pretty simple. You just create a ViewSynchronizer object, and then you specify what kind of mode you want to synchronize. For in this case, would be invisible range, and then you would connect each of your widgets to the synchronizer, and then you might do an initial synchronization if necessary. So right here we have something, a lithology and a line chart that right now the view synchronizer hasn't been enabled. You can see when we try to zoom in here, it does or if we zoom in here, or we pan, the changes aren't represented between the aren't affected between the different widgets. As for setting it up, it's pretty simple. You just have these couple lines of code where you create the synchronizer, you connect it, and then you do an initial synchronization. And then now you can see that when we zoom on the lithology, it affects the line chart. When we zoom in on line chart, it affects the lithology, and when we pan, you can see that the visible ranges also change on both widgets. In this current implementation, oh yes. Mm-hmm. Oh yes. Over here, you can see that in right here, we're only synchronizing along the vertical because the lithology widget, we only want to synchronize the vertical. There's no need to synchronize across horizontal. So you see right here where we're connecting the widget, there's also a disconnect method that you can disconnect widgets from the synchronizer. So by, oh, sorry. It's so you would be in those cases where you're attaching a tool listener, you can also remove those listeners. Yes. So by default, when you connect a widget to the view synchronizer, they're in a many-to-many relationship. So then any particular widget both sends synchronization events and receives synchronization events. But this isn't. You can also specify one-way relationships where you might have a master widget that you want all the other widgets to synchronize to. But if you want to zoom in on those, like on those slave widgets, they don't synchronize back to the master. They don't pass synchronization events back to the master. You can you see when you connect widgets to the view synchronizer, you can set your custom synchronizations, and you can also set custom transformations as well. Can you go back to the previous? Yeah. And are there any questions on either tool listeners or view synchronizer?
Yeah, is this widget synchronization is available for It's part of Karnak.
The general approach. I mean,
Yes.
It's part of Karnak, right? So Karnak is the low-level capabilities that are available in all the different libraries.
Yes. Say, for instance, that you have a 3D schematic, right? You have a 3D schematic.
I mean, this is a separate package.
Separate. So what I mean is that you have a 3D schematic here, and then you have a 2D schematic here. Then you can synchronize.
We have, but it's a little bit different. This one is done for 3D.
Plain. Yeah, this is plain.
We have one demo probably. If you do have distribution, we can show. Here, for example, we have a demo. It's part of ES6 demo set. It has the name schematics to D3D. So if you run, so you can see this like 3D schematics. So change camera, it will automatically.
Suppose you want to highlight that certain component, then see whether both of them.
Yeah, I think it should be done only manually. So here, so you need to listen some tools and apply changes. Similar what Jason showed. ViewSynchronizer itself, what we demonstrate, is a little bit different because here potentially it can be possible to write special extension for this one, but it's not. That doesn't come by default. For example, here if you like start to zoom in, zoom out, it's no effect for 3D part or reverse. So this one just synchronize only with different. Oh, sorry. Yeah. Just with projection to the current plane. But here, what is good, it takes the same data model. So because we can share a data model between 2D and 3D, and you can apply changes.
So when you're moving the right side around, then it's going to be changing.
Yeah, of course. For example, just let's see, like do it like this. It's automatically project on your plane, which you can see. This demo itself, it just demonstrate some different smoothing for trajectories, which I mentioned, because your width of your track is it's a little bit big, so you don't want to see some overlapping.
Suppose on the left-hand side is a deviated, on the right-hand side is a vertical.
Mm-hmm.
Is that you can just moving the
cursor? Yes, you can. Think for what do you?
What's up?
If you want to synchronize deviated and linear schematics together.
Yes.
So I think what do you want to synchronize? Do you want to view position?
Yeah.
Yeah, yes, you can. So
Any other question, guys?